Hello, everybody, and thank you for joining me today. It's Allan Laboucan with the Rocks and Stocks News Show, and I've got a new show about pirate gold. Um, I I'm really impressed with how much content Pirate Gold puts out, and I'm also happy to have them on as a sponsor of my work and my shows. And what really makes me excited about the content that they put out is not only that it helps you as in my audience to understand more about pirate gold. It helps me as well, but also it helps you as an investor understand what to look for in projects such as what they're working on. Now, I've often heard some of my peers or fellow commentators on the space talk about people and that you want to stay focused on good people. And every company says they have good people, but what really separates the wheat from the chaff for me is I'm a believer in action speaking louder than words. And you can learn a lot about the people involved in a company by their actions. In the case of Pirate Gold, they put out a lot of content, and I think that's because they've got a lot of good stuff to talk about, and they want to show it off, and they also know how to explain it. And so today's show is really based on a video. They announced on Friday that they started drilling on their Crippleback area on their Treasure Island project. And Crippleback is a little bit different than their Moosehead project. Moosehead is your orogenic kind of system, and Crippleback is different. And so Greg Matheson, who is the VP Exploration, he talks about it in this video that I'm going to sort of start and stop when I hear things that really stand out to me and how I can help maybe translate his geo speak into non-geo, translated into non-geo or investor speak, if you will. And just to put Greg, I'll talk a little bit about Greg. Greg was part of the Newfound Gold team from really early, and they found a lot of high grade gold at Newfound. And then, as Newfound, by the way, which is one of my picks, was advancing towards bringing the Queensway project, which is about 25 kilometers to the east of Pirate Gold's Treasure Island project. He and Denny Laviolette, who's the CEO of Pirate Gold now, decided that they didn't mine building really wasn't their thing, and they wanted to keep on doing exploration in Newfoundland. And because Wasocum and Minerals at the time had such good projects, they wanted to come in and expand on the land, create a new company called Pirate Gold, and that's the sort of background on Greg and Pirate Gold. All right, so let's get on to the video now. And here we go. I just need to do a screen share. And of course, they changed things a little bit on my software here, but I figured it out. There we go. All right. So there's the YouTube video. And by the way, in addition to the news release that they put out another edition of their Treasure Hunter series. And that you can find in their news release that was out on Friday. All right. So let's get rolling here. And oops, I jumped ahead of myself. All right. I'll hit play.
In between is
Oh,
ancient oceanic and volcanic
hold
material
on,
being
hold
mapped.
on, hold on. Here we go. There's the start of it.
Greg
Let's go.
Matheson, the VP Exploration for Pirate Gold Corp. And thank you for joining us today as we look to add some details on the geology of the Crippleback region of the Treasure Island project. I plan to cover several exciting prospects and definitely a little bit of warning here that this will be a more technically focused presentation, and it's a little bit lengthy, but hopefully we're able to lay out some of the reasons we're so excited about this region of the Treasure Island project. We're going to start off by looking at this diagram of continental collision margins, and this is important because Newfoundland sits on a number.
Right away, Greg gets into something that has intrigued me since I was about 8 years old in elementary school. So to age myself, that would have been about 1969, 70. And to put that into context, this was when plate tectonics was first being talked about and researched significantly and has continued since then. But why it was important to me, and I think, possibly what led me into the business that I've been in for the last 30 years, is that I had some attention issues when I was in school, and these attention issues would often get me into trouble. And so I created some mechanisms to keep myself out of trouble. And one of those was that I would try to focus on something other than the other people in the classroom, the teacher, and everybody else. And back in those days, they had maps of the global maps on the top of the walls. And back then I would look at them and look at them and study them. And I started to think that, oh man, those continents look like they were all one one thing that was sort of broken into several pieces. And so one day got my tracing paper out and I went to the globe, the round one, by the teacher's desk, and I started tracing out the continents. And my teacher came over to me and said, Allan, what are you doing? And I said, well, I'm tracing out the continents because they look like they're pieces of a bigger puzzle that was all one at one time. So I didn't think this was overly remarkable. But she did, and she went and got the science teacher, and the science teacher came over and did the same thing, asked me, "What are you doing?" And I explained that I was tracing the continents because I wanted to see if I could put them back together. So then he and the teacher go off and come back with about five other teachers, and they're talking amongst themselves. And then they come over and ask me what I'm doing, and I tell them again. And so then they left me alone, and I went and I finished tracing out my continents and cutting them into individual pieces, and then I put them back together. Years later, when I got into the mining business, I realized why this was kind of unique, for why the teachers might have been interested in what I was doing. As I said earlier, this was when plate tectonics was just starting to be understood. Fast forward to now, and plate tectonics play is much better understood, and that's what this tectonic controls on global gold resources is talking about. I'll let him, because I'm going to stop him again in a moment.
Of continental collision margins. And firstly, we're going to look at the accreted terrains, which cause the formation of thrust faults deep into the crust. When water is squeezed from the deep rocks, it harvests metals, and those metals then get driven up along the faults until the fluids reach temperature and pressure conditions that form into veins. And this is what we generally refer to as an orogenic gold deposit.
Okay, can't hold myself back. So in plate tectonics, you've got important plates. One are your continental plates, which is represented by this. And then you've got your oceanic plates, which is represented by this. Now, why that became really important in my life is because when I was very early in the mining business in the 1990s, some Canadian diamonds were being discovered. And we were starting to learn about diamond formation and how in emplacement as this was emerging. And one of the important parts of diamonds is that you need carbon, you need pressure, and you need temperature in order to get a diamond to grow. All right. So the first question is, well, how did the carbon get deep below the Earth's crust in order to turn into diamonds due to the heat and pressure? And so what that is you've got the ancient sea life that would go to the bottom of the ocean. And then as the oceanic plate subducted underneath the continental plate. This was your path of where the carbon came from and made its way down to below the Earth's crust, where you have the temperature and pressure to turn carbon into diamonds. Now, what's a little bit different about diamonds and orogenic gold is that the the how the diamonds then make their way from deep in the below the Earth's crust up towards the surface is that there's a volcanic event or called a kimberlite that grabs those diamonds and rapidly brings them towards the surface. In diamond exploration, we call that the bus. Whereas what is more important in orogenic gold systems is that Greg will talk about this. You have these cracks in the earth, these deep crustal faults that are they're basically cracks in the earth. That the fluids from here that carry the gold make their way up those structures, those faults, those cracks in the earth. Okay, so I've been studying this stuff for a while, so I hope I didn't make it too complicated, or I tried to translate a little bit about what Greg is talking about. But that is the continent making process geologically, or part of it, that is important for orogenic systems, porphyry systems, epithermal systems, and he's going to get into all that. So I'll let Greg take over again.
Second
Oh,
environment that we want to look at here, which is important on the continental scale, is a subduction zone. And that is when one plate is sliding below the other and the lower plate begins to reach deep into the earth. And as it does so, it begins to melt, and some of those melts become buoyant. And then they can rise closer into the crust, carrying metals, and form what is known as a porphyry deposit, which can become enriched in copper, gold, or molybdenum. Today, we're going to discuss how both of these events could be at play at the Treasure Island project. So,
before he goes on here further, I think it's really interesting what he just said about that porphyry and orogenic systems can be present at Crippleback. And why that's important is sometimes some of the great mines in the world are they have primary and secondary enrichment of a zone. And so this can make for a great mining opportunity. And there's there. It looks like that's what happened at Valentine Lake, which is to the south, and you're going to see that in the map. I'll let Greg continue to talk about orogeny, Appalachian orogeny. But what I would add is that this is Ireland over here in Northern Europe, and here is Newfoundland. And you'll see this dashed line. That is one of those deep crustal cracks. And why it's important is that you've got some really important orogenic gold systems over here in Ireland, and also now Newfoundland is emerging as the same kind of a situation. And I'll let Greg continue.
continue to talk about continental collision. This brings us to the concept known as orogenies, or in this case, the Appalachian orogeny, which is The beginning of Newfoundland, which is shown at the center of the diagram. The island was formed millions of years ago during the Appalachian orogeny, which means we have the collision of two ancient continents being Laurentia, which is the North American plate, and Avalonia, now the African plate. And sandwiched in between is ancient oceanic and volcanic material being the Iapetus Ocean. The Appalachian Caledonian Belt can be seen from what is now the Baltics all the way through the Carolinas and effectively the entire eastern seaboard of North America. This is an accretionary event and what is commonly called a mountain building event. However, these mountains have long since eroded. Zooming into the island of Newfoundland, we can see the major margins of these ancient continental terrains.
So those would be the Laurentia, which is your main, your North American plate or crustal or continental plate. Avalonia is over here, and then in between are he'll explain that. But the main thing is here you've got about a half a billion year old rock in at both Valentine Lake intrusive suite and Crippleback Lake. And basically, he'll talk about how these rocks, these orange rocks, and I'm not even sure what color that is. I'm kind of colorblind some or color challenged sometimes, but the darker colored rocks here are these rocks that are windows through these younger rocks that are below this these rocks that cover these older rocks.
Colonia to the east, Laurentia to the west, and sandwiched in between, accreted oceanic and volcanic terrains. The one exception to this is we notice here there are a number of Avalonia inliers in the center of the island. These are effectively basement rocks from Avalonia sticking up through the much younger oceanic rocks. The more prominent of these is the Valentine Lake intrusive suite and the Crippleback Lake intrusive suite.
So that's your circles here and here.
Of which are age dated as Neoproterozoic, which makes this area of the province very unique, and we will explain further as to why this is an important distinguishing feature. Another key feature that is formed during the orogenic events is the formation of large-scale crustal fault structures, shown here as dashed lines that cross the entirety of the island.
So this Valentine Lake one is particularly important because it is the one of the most important cracks or faults and in Newfoundland and down at the southern end of it is where you find the Valentine Lake mine that Equinox is developing and bringing into full commercial production in 2026. This over here is a model of an orogenic gold system. Okay. And as you can see here, these form at very deep parts of the below the surface. You have different kinds, epizonal, mesozonal, hypozonal. The epizonal are closer to the surface, and mesozonal are deeper. And a lot, some of the great mines are in the epizonal and mesozonal windows, such as in Red Lake, the great mine that Goldcorp had in Fosterville in Australia, and that's what the model is. So these cracks, as you can see, are very important because here you got sort of the one side of the crack, and here you have the other, and the fluids that carry the gold come up, and you can't see it as well, but there are secondary cracks that are very important for the gold mineralizing or pooling of the gold so that you've got something to mine there. So I look at these deep cracks sort of as the highway and the Secondary cracks are kind of like the roads that come off of a highway. And in an orogenic system, you need the highway and the roads that come off of it.
These are the conduits for gold mineralization. And shown in blue is a critical fault structure called the Valentine Lake Fault. This particular fault hosts the largest known gold deposit in Newfoundland, the Valentine Lake mine. And you'll notice also that the Valentine Lake Fault crosses both the Valentine Lake intrusive suite, which hosts the gold mineralization, as well as the Crippleback Lake intrusive suite.
He mentions cross it, but it actually is right beside it. So you've got the intrusive suite, and then right at the margin, you've got the crack, and so the crack and the intrusion rocks are really important at Valentine Lake, and I think they will be proved to be very important at the Crippleback project or area of the Treasure Island project.
Gold's Treasure Island project is shown in blue and covers over 92 kilometers along the important gold-bearing Valentine Lake Fault.
Now, I talk about Newfoundland being the potential to be the Abitibi 2.0. And why that's important is that in the Abitibi, you've got the Larder Lake Fault and you've got the Cadillac Larder Lake Fault and the Destor Porcupine Fault. And so these are parallel cracks in the earth, if you will, that are really important. And as you can see, there's cracks over here on this side called Valentine Lake, and over here is where the Moosehead, or I'm sorry, the Queensway project is, and you've got other cracks that are important. So that is one of the foundational things of why I think that Newfoundland could be the Abitibi 2.0. Now, what's super exciting is that this the Abitibi 2.0 is sort of like being able to wind the clock back 100 years and be able to control like 90 kilometers of one of those important cracks in the earth at the Abitibi. But in this case, Pirate Gold owns a big chunk or most of the majority of one of those important cracks. And then about 25 kilometers to the east is where Newfound Gold has another big chunk of that crack. So if I'm proven right that this will be the Abitibi 2.0, the key players in that, it's like they have the Larder Lake, Cadillac Larder Lake break, and the Destor Porcupine cracks are basically in two companies. One of them being Pirate Gold, and that's not lost on me as to how important that is in what I believe will prove to be the Abitibi 2.0.
Which includes the Moosehead Zone, the most significant known zone along the fault outside of the Valentine Lake mine. But we won't be covering that today. Instead, I want to focus on the Crippleback Lake region.
By the way, folks, just last weekend, the Pirate Gold put out a new corporate presentation, which I did a play-by-play on and went over, and there was a lot in there about Moosehead. So I invite you to go back to last weekend's show, when I talked about Pirate Gold's corporate presentation.
Highlighted in the center of the screen. Zooming in further, we can see the relationship between the Valentine Lake and Crippleback Lake intrusive suites. Most importantly, we highlight their structural positioning relative to the Valentine Lake fault. Comparison to the Valentine Lake intrusive suite, the Crippleback intrusive suite is vastly unexplored with almost no drilling, and Pirate Gold is the first company to aggressively test its potential.
So what stands out immediately to me is that this is the Valentine Lake intrusive suite, and here is the Crippleback. So these are rocks from deeper that intruded upwards. And in the case of Valentine Lake, on the other side of the Valentine Lake fault, in the intrusion is where the Valentine Lake mine is located, which is a multi 5 million ounce system where they're finding more gold and they're bringing it into full commercial production. And now, in addition to, as you can see, the Crippleback intrusion is substantially larger. I would guess like 5 to 8 times larger. And also, I find this really intriguing that right at the margin is where the Valentine Lake fault is located. And then you've got the Valentine Lake shear, or sorry, Valentine Lake intrusive suite there. And you go up the highway, up the road, and you've got the Valentine Lake fault zone continues at the margin or at the edge of that intrusive suite. And so it's sort of a look-alike, if you will. I guess that's the easiest way. I don't know if I'm saying something I'm not supposed to. If I am, sorry for the forward-looking statements. But yeah, from an exploration perspective, and I've got about 30 some years of exploration, these are the things that stand out to me. Now, another thing that stands out to me is that you see how this Valentine Lake intrusive suite, it basically has the one fault crack right beside the intrusion. Whereas here you kind of get it separating into two, and one on the north side, one on the south side. And that southern one follows the intrusion. And then you've got what is called dilation here, where the rocks actually open up. This here area here is really exciting to me. Often I'll look at, when I'm looking at these faults, I look for bends in the faults or jogs in the faults. And when you see this kind of action here and multiple faults, and you're going to see more of that in the primary and secondary faulting, this is a very highly prospective area for me, as is where it bends here, and you see some displacement down here. This is all very intriguing to me because that's where you've got great rock preparation for those fluids from deeper to make their way up into.
Also point out that the Crippleback intrusion has roughly double the strike length as the Valentine Lake with over 37 kilometers. The other feature worth noting here is the Rogerson Lake conglomerate. This is a fault-filled conglomerate that is much younger than the intrusions, but is a lithological marker for the Valentine Lake fault and is found along the southern margins of both intrusive suites. This cross-sectional diagram comes from Ian Hansberger at the Geologic Survey of Canada, who's
So this cross section helps you to understand a little bit more about subduction and the various different rock packages. And when I always try to break things down to make them simpler. Maybe it's because I'm a simple-minded guy. I don't know. But what when I look at these different layers, it can be like a cake, or I think of it somewhat like the rings on a tree. And as you can see, there's different rings on these trees, which are the different layers of rocks. And this can also be very important for the emplacement of metals bearing fluids.
been studying the Valentine Lake belt extensively for the past few years. There's a lot of information contained here, but it gives a great illustration of the tectonic model for the Valentine and Crippleback intrusive suites, and it answers a number of questions I hope to summarize. Anybody wishing to conduct your own research, please do look up Ian's work. Through the work of the GSC, they have shown that around 425 to 418 million years ago, we see a subduction zone model, and that something is happening at great depths, such as delamination or slab breakoff, which is causing extension in the crust. The key takeaways for me are firstly that we see the uplift of the Neoproterozoic basement rocks, which basically shows how these older rocks get here, aka the Crippleback and Valentine Lake intrusive suites, which are much older than the surrounding terrain. Secondly, we see the development of crustal scale extensional fault system. This also causes the emplacement of calc-alkaline igneous rocks, which is a feature I'll come back to further on. And finally, we are depositing an
Magmatism, basically, you're talking about the magma, and that can also be very important to the whole geological process of how metals, fluids make their give you the right environment for metals to form and make their way up closer to the surface.
conventional fault fill sedimentary unit, the Rogerson Lake conglomerate, which lies unconformably on the Valentine Lake and Crippleback Lake intrusive suites, which I mentioned earlier as a marker unit for the Valentine Lake fault in this region. This event is the prelude to orogenic gold mineralization, as there is a thinning of the crust, increased heat flow, and hydrothermal fluids begin moving in the crust.
Sorry for all the interruptions, but I just hear things that really stand out to me, and I got to talk about them. What he's talking about is the that it's sort of the ideal model for an orogenic gold system right at Crippleback, but later he's going to talk about how the potential for porphyry kind of systems are there as well. He touched on it earlier, and I think he touches about on it again later. Here, I'll let it continue.
Again, another diagram courtesy of the researchers at the Geologic Survey of Canada, which outlines how we're forming the orogenic system at the Valentine Lake and Crippleback Lake intrusive suites. And this was during a subsequent tectonic event around 418 to 390 million years ago. In the diagram, we can see the reactivation of extensional faults as thrust faults, which create a fluid pathway to tap gold-rich fluids at depth that eventually migrate along the Valentine Lake fault, depositing in the footwall. And while we know these were deposited at the Valentine Lake intrusion, where Equinox's mine is now located, we are looking for that same depositional environment at the Crippleback Lake intrusion, which is virtually unexplored for this type of mineralization. And it's always remarkable for me to see these geologic environments, this perspective in Newfoundland, that have seen little to no exploration. Looking more closely at the interpreted geology of the Crippleback Lake intrusive suite.
So colors change, but what he's talking about doesn't. Again, here you've got the Valentine Lake fault zone. In here you've got the intrusive rocks. What stands out to me is I find this bending area here and the separation, like you see these two faults down here, they're almost really close to each other. And then up here, they sort of separate from each other, or it's also called dilation, where you've got them sort of separating. And this is a fantastic place to be looking for mineralization. But then you're going to see all these other lines here, all these northern arm fault, and sandwiched in between the northern arm fault, which goes up here, and the Valentine Lake fault, which is down here, you've got sandwiched in between that is all of this intrusive rock. And inside of that, you've got more of these cracks. And so this is when I see this sort of stuff, this dilating area bends up here, bends here, where they come together here. And these sort of things are all really important indicators, or as I like to say, they're the breadcrumbs that can lead you towards finding a deposit. And the X marks the spot are areas where they want to really get, I believe that I don't want to put words in their mouth, but I believe they're going to get to these because look at here, Buccaneer Pond, where you're getting gold mineralization. And notice how you've got the faults crisscrossing here, coming together here, cross-cutting here. These are all, it's not a wonder to me that you get this kind of gold mineralization at these points with all these X's on them.
It's not a homogeneous block of boring basement rock, but rather it's made up of felsic volcanics, mafic intrusives, and largely quartz monzonite. We can also see the geophysically interpreted segment of the Rogerson Lake conglomerate, the fault-filled conglomerate closely associated with gold mineralization at the Valentine Lake mine. And this extends for over 35 kilometers along the southern margin of the Crippleback intrusives. Also in the map are numerous geophysically interpreted fault structures that cross the Neoproterozoic basement rocks. There are two regional scale faults with the Valentine Lake and along the southern margin highlighted in blue, and the subparallel northern arm fault along the northern margin highlighted in purple. What really gets exciting
Then again, pinched in here is that intrusive rock.
at this scale is that you can see, in addition to the regional scale fault structures, we have over 100 kilometers of prospective second order structures crisscrossing the intrusion and linking the two regional scale.
And I would harken back to that model that is earlier in this video where it shows you how you've got the primary cracks and the secondary cracks are also very important.
Faults. And this is where we would typically expect to see orogenic style gold. While past exploration is very limited, three areas of the project contain historical evidence of orogenic gold. Firstly, the area in the southwest labeled as Buckler Ridge. This is closely associated with the Valentine Lake Fault, and till sampling here has identified up to 43.
Now, this is really interesting to me. Sorry for all the interruptions here, but here you got the Valentine Lake fault in blue, and then you've got another parallel fault, which is coming up here. Then you've got another fault that's coming down here. This area right in here is very exciting to me. And I think it's why it's one of the ones that Greg is focusing in on.
Pristine gold grains in this region, as well as surface float.
So when he mentions pristine gold grains, what that means, folks, is that if a grain of gold is in a rock and it breaks off from that, and let's say it makes its way into a river, over time it will roll around in that river and get very rounded. Whereas when it freshly comes off the rock, it won't have the rounding. It will be it's called angular, or you'll see these flat lying sort of textures to the grain of gold. That's called pristine. And why that's so important is that it tells you that, where you find a pristine grain, it's probably not far from the bedrock that it came from or the hard rock that it came from. And the ice direction is coming up in this direction. So you want to look back down ice from where you see these pristine grains.
Lab samples yielding up to 1.7 grams per ton gold. Those grades may not sound impressive, but recognize that much of this region is covered in glacial till and contains no diamond drilling, which is the only reliable way to assess the bedrock. The second area with evidence of orogenic gold.
Again, I would add in there, folks, when you've got these pristine grains, to me, the grade isn't really as important in the as a breadcrumb to look for the treasure you're looking for. The fact that the grain is pristine, it tells me that there is likely a nearby source of where that came from. Earlier, I mentioned that I had spent a lot of my career in diamond exploration, and we see the same thing in diamond indicator minerals. And you tend to see a lot more of them, like thousands in a samples. And you can determine the texture. You can see if they're rounded, which suggests that the glacier moved them along direction from where they came from. But if they're angular grains or they don't have the rounding, you know that you're fairly close, maybe 100 to 500 meters from where that came from. And that's similar to what you're looking at when you hear pristine grains. So it's not so important the gold grade at the surface. It's using that pristine grain to then help you find the bedrock source of where that came from. And then the grade starts to become more important because now you're into the source and you don't have this displacement of moving it from where it came from. You're right in where it came from.
Lies to the northeast along the northern arm fault labeled Buccaneer Pond. In this region, we have numerous historical surface grab samples, some with high grades up to 21.8 grams per ton gold, and no drilling has ever tested any structures associated with the northern arm fault.
Again, this, you've got the convergence of faults, the cross-cutting of faults, this is a highly prospective, and no, it's not a wonder that they find a lot of gold up in this area down here, and then all of this area here that I'm crudely making a path around, you see this same kind of phenomenon where you've got all of these structures coming together, crisscrossing, parallel to one another, all very important stuff. I think that this is going to become more and more important as they poke holes into it.
Lastly, we look at Scurvy Pond. This is a brand new fault structure discovered by drilling in 2024. The intercept recorded polymetallic veining containing 1 gram of gold mineralization, 34 grams of silver, and 0.23% copper. In 20
Later, Greg is going to talk about epithermal and porphyry systems. And when you start seeing gold and silver, that is classic sort of epithermal. And epithermal veins tend to be distal to the porphyry that they came from, or a distance from the porphyry that they came from in the epithermal porphyry model. And so when you start seeing gold and silver, because the orogenic system that they've been drilling at Moosehead is gold, okay? Whereas here you're starting to see gold and silver, which could be why, the epithermal system and porphyry makes sense. And there's also copper showings as well. So it's all this is all how a theory or a thesis evolves on an exploration project. And that's what's happening in real time and what Greg is talking about.
24, the predecessor to Pirate Gold Corp, completed 9 drill holes at Crippleback Lake, covering a variety of targets. The focus was on exploring surface targets within the Crippleback intrusive suite and not necessarily targeting the Valentine Lake mine setting. As you can see from the image above, this drilling was centralized on a relatively small area within the Crippleback intrusive suite, but achieved some very significant discoveries that we'll discuss further on.
And in this case, you see DDH, that's a diamond drill hole. A lot of these other ones are grab samples. And I find it interesting that, where these, that one fault and the other one cross is where they drilled in 2024.
One of the significant discoveries from the drilling in 2024 was CL2406, which intersected a newly discovered fault structure hosted in graphitic sediment that yielded promising assays of 1 gram per ton gold, 34 grams per ton silver, and 0.23% copper over 0.75 meters. To date, this is the only drill hole to have ever tested this target. What's more promising is that we see through geophysics that this graphitic host projects much further along strike for tens of kilometers without any drilling.
So you see the graphitic host he's talking about and the quartz veining that's in close proximity. So if you can find a lot of the graphitic rock, you got a good chance to find more of the quartz as well.
Looking at a planned view of the Scurvy Pond discovery in CL2406, overlaying on a preliminary resistivity image of our ongoing EM magnetic airborne geophysical survey, which is covering the southern part of the Treasure Island project, we can see the graphitic fault intercept in 2406 has a strong conductive response, and this unit is traceable along strike for tens of kilometers well outside of this image. And no other drilling has ever tested this prospective fault structure, which is one of many crisscrossing the Crippleback intrusion.
So the geophysics are confirming what the structural interpretation is telling them. So they're seeing the structure here and the geophysics that back it up. Here you're seeing a similar type story along this crack here and right there and down here. So it's those changes in the geophysics that are or the difference from what's happening elsewhere that is giving you an anomaly. It's anomalous. It's different than what's around it. So when you start to layer the the structural story on top of the geophysical story, on top of the mineralization. Again, this is all using the geological breadcrumbs, if you will, to help you vector in to finding something that could be a mine.
We're going to move on from the orogenic gold potential and talk about another exciting aspect of the Crippleback region. And we come back to this basic model. Many of the viewers are likely familiar with copper porphyry and epithermal style deposits. But for those less familiar, we want to outlay some of the basics of why these deposits matter and why we think there's potential at Treasure Island for them to occur. Geologically speaking, porphyry deposits are formed from oceanic crust that has been subducted along continental margins to great depths, at which point it starts to melt. Because these molten rocks contain large volumes of water, they become buoyant and start to migrate over long time periods closer to the surface. They're essentially floating up through the crust. The melts can contain large amounts of metals, and the deposits they form are the world's largest sources of copper mined today, along with significant amounts of gold, molybdenum, and other metals. Porphyries are typically lower grade but contain massive rock volumes, and the overall large endowment of contained metals.
The porphyry can be lower grade and big, but the epithermal veins that come off of them can tend to be much higher grade. Like I live in Mexico, and Mexico has produced somewhere around 25% of the silver ever produced in the history of mankind, and most of that comes from epithermal veins. And they're high grade, they're narrow, they're steeply dipping, but they make for wonderful underground mines because the rock is so valuable. Not to say that lower grade rock can also be very valuable when you have a lot of it and you can mine in a more bulk sense. That's the epithermal gets me excited, as does the porphyry.
An interesting target for exploration. Epithermal deposits also result from the same mechanisms as porphyries but are related to hot fluids being circulated by the porphyry, harvesting metals and depositing them closer to surface, similar to hot springs.
What Greg has really described there is the porphyry epithermal model. You've got the porphyry down below, which is creating the heat. It then interacts with the water above it, and you get these boiling zones of epithermal veins that are sometimes great mines as well.
Epithermal deposits are known for containing very high precious metal grades, but lower tonnages than porphyries. For gold, porphyry and epithermal environments are found along convergent margins throughout the world. However, they are predominantly found in younger geologic terrains. This isn't because the formation of porphyry epithermal deposits is a new.
You can see the ring of fire going down the North America, South America, over on the other side of the Pacific. And notice how, where you find the blue, you also find the gold. So that's the why the model is what it is because of this close association between porphyry and epithermal systems.
Phenomena, but because they are formed at shallow crustal levels and many of them have been eroded from older terrains. Nonetheless, there are several prominent examples from the Appalachian orogeny, including several occurrences in Newfoundland that have survived erosion. There are several well-known porphyry and epithermal deposits throughout the Appalachian belt. Most well-known of these is the giant copper porphyry and skarn deposit called the Gaspé copper in eastern Quebec, the Hale epithermal style deposit in South Carolina, and most relevant to Treasure Island is the Hope Brook epithermal deposit in Newfoundland that was mined from 1987 to 1997 and to date has been the largest producing gold mine in Newfoundland. So, could the conditions exist for copper porphyry or epithermal mineralization at Crippleback? The short answer is we think it's plausible. The first scenario is less likely, but it is possible we have preserved Neoproterozoic mineralization related directly to the quartz monzonite, which is the rock type most closely associated with porphyry-style deposits. The second scenario involves the convergent margin discussed previously in the late Silurian, which caused calc-alkaline magmatism around the Crippleback Suite. This is thought to be occurring just before or during the emplacement of orogenic gold, and has been suggested this magmatic event may also play a role in the orogenic formation, as polymetalloid associations with gold in the Valentine Lake belt have been found to occur along with elements such as copper, antimony, bismuth, tungsten, and tellurium, suggesting fluid sources could be mixing.
That's a big one to me, folks. When you get these mixing, or it's like primary and secondary enrichment into a zone that can juice up that zone and make for really exciting the potential for mines with juiced up systems from primary and secondary enrichment.
Looking at a plan map of the geology of the Crippleback intrusive suite, one geochemical marker stands out, and that is there is a large concentration of copper and molybdenum surface showings hosted in the quartz monzonite at Crippleback Lake. We can also see a similar concentration of copper molybdenum occurrences along the same fault corridor 10 kilometers to the northeast at Buccaneer Pond. The presence of molybdenite, chalcopyrite, chalcocite, and malachite within the quartz monzonite certainly leads us to think about the porphyry as a depositional model.
I mean, basically, sometimes it's deductive reasoning, folks. Like if you've got, you start to ask yourself, well, why is there copper here? Why is there gold here? And these questions can lead to a thesis that is hopefully proven up with the truth machine or the drilling. And now he's going to talk to you about the drilling and what this is being seen in that one hole in 2024.
Why am I discussing porphyry and epithermal deposit models? Well, pictured here is an entire drill hole from 2024, CL 2409, the very last hole drilled. This drill hole is comprised of quartz monzonite and volcanic sequences typical for the Crippleback intrusive suite. What's notable about the drill core is the extensive clay alteration and very high pyrite enrichment. The entire 220-meter hole has been subjected to intense argillic alteration, something that's not common outside of porphyry and epithermal mineral systems. So, why is understanding alteration important? In the porphyry environment,
So here is your porphyry model, and distal to the porphyry are your epithermal veins that come off of it. Now, before Greg goes into this more, I kind of often I'll talk about how you can look at exploration, sort of like think of putting a temperature gauge down this through this rock. The closer you are to the heat is where you get is where the mineralization can come from. And so sometimes I'll see projects that have what would be called a technical success, and then investors aren't interested in a technical success. But sometimes those technical successes can turn into big successes. And why that happens is if you're in the wrong part of the temperature gauge, if you will, you're going to find a technical success at the wrong part. And if you drill deeper into it, you get closer to the hotter part of the system, and that's where the magic happens.
the widely recognized zonation that occurs as we approach near to the core of the porphyry. This is a schematic of the alteration surrounding a porphyry deposit, and we see that the mineralized core of the porphyry is located here. But as we move away from the core, we start to enter more into the argillic type of alteration we see in drill hole CL 2409. It doesn't guarantee that a large porphyry deposit is present, but suggests that it could be nearby, either laterally or at depth.
Now, he talks about how this can lead you somewhere and not really being indicative of size. But I think it's worth pointing out that the alteration in that 220, there basically was 220 meters of alteration. And there's an old saying in the mining business that big systems leave big footprints. And a 220-meter intersection of alteration is what you would call a big footprint. Now, like he says, it doesn't mean there's a big deposit there, but big systems have big footprints, and that's what stands out to me on this project is the amount of alteration. Now, what is alteration? Well, when those metals bearing fluids get into the country rock around it, or even inside of the zonation of the system, it alters that rock chemically. And so that alteration is really important in the exploration. Now, if you hit a hole full of alteration and modest to good grades, people don't really get excited, but the geologist and the explorer will because that's what can lead to big success when you understand the system, when you see a lot of alteration, and you then vector into the guts of the system, if you will.
DL 2409 wasn't the only hole in 2024 that encountered strong clay and pyrite mineralization. There was actually four holes along a kilometer of strike length. The image here is a cross section.
So there again, he's talking about four holes, a large area, and lots of alteration in each hole. Now, that just means you got to roll up your sleeves and keep looking because something caused all of that alteration.
Showing the area of alteration, which appears to be fault constrained along the margins of a quartz monzonite. The altered rock contains 3 to 8% pyrite and importantly contains enrichment in a number of metals with copper, zinc, and lead, as well as shown in the image is gold. So throughout the entirety of the alteration zone, we have highly anomalous gold values up to 670 ppb. This alteration style is closely associated with both copper gold porphyries as well as high sulfidation epithermal environments. Called alteration zoning is very important in these environments. And in modern exploration, we have cutting edge tools that weren't available to explorers previously. One of the best tools for mapping clay alteration is the use of spectral analysis. By measuring the wavelengths of light reflected back from the rock, we can determine the composition of clay minerals. Specifically, when dealing with white mica, we can see that there is a zonation occurring in these holes that points to the potential source actually being further out from the fault as the white mica wavelengths are decreasing. This could be counterintuitive, but suggests that the alteration isn't a result of the quartz monzonite seen in the footwall of the fault, but something else. Well, this alteration pattern does resemble what we would expect to see around a copper gold porphyry system.
So basically, these lines are sort of in agreement with what you're seeing over here uh, as you get away from the guts of the porphyry and start to get distal to it. You see these zonation that he's talking about.
Noting the similar colored contour lines of the white mica compositions in the diagram to the lower left, and comparing that to those on the section to the right, we would theoretically be getting closer to the core of the system moving to the north. The higher metal concentrations, however, are more closely associated with the fault contact, but they are anomalous throughout the alteration zone, with no samples here reporting less than the method detection limit. This alteration style can also lead us to an alternative deposit type, the high sulfidation epithermal system. Shown here is the basic model of a high sulfidation epithermal style of mineralization. These deposits are genetically linked to porphyries.
So again, here you've got the porphyry, and here you get these high sulfidation epithermal systems that are disseminated. So you've got the vein here and the veins coming off of the porphyry, and then you get into a rock package that, some call like a sponge, where that material that can then get disseminated, the gold, the silver, and the copper can get disseminated out into that rock that's like a sponge. And so that's what he's talking about there.
Occur at much shallower depths. They are formed when circulating fluids come in contact with and become superheated by a porphyry, harvesting metals and depositing them in high-grade style veins or other disseminated forms.
I've described this sort of like a, pot of boiling water. So, you've got the heat down here, and then you've got your pot, and inside of that is your water. And all of these, the water, the heat, the minerals, they're all part of that boiling pot of water, if you will. And that's why I use that analogy.
I wanted to point this out as another plausible explanation for the widespread clay alteration we see at Crippleback, and to show that as exploration geologists, we have several theories to examine each time we are given certain bits of evidence. These deposit types occur at much shallower depths and would imply that very little erosion has occurred to preserve these types of systems. This is not out of the question, as we know several epithermal deposits are preserved in Newfoundland, including the Hope Brook mine referenced earlier. We can see on the right is a plan view of the 2024 drilling, illustrating the surface projection of the fault contact, shown in the section on the left, which starts to give a glimpse of how extensive this alteration is. The on-strike distance from drill hole 03 to drill hole 7, 8, and 9 is close to 1,000 meters. This is where things really start to come together, as we can see that the projection of the fault contact matches almost exactly to one of the geophysically interpreted faults, which can allow us to project that plane much further along strike. It seems likely that this fault is playing a role in controlling the mineralization. This continued to get more exciting when we overlay the preliminary EM data and start to see that the alteration in the drill core is correlating almost exactly with an area of low resistivity. This means that there is a conductive response, likely due to the high sulfide content noticed in the core with 3 to 8% pyrite. It also means that geophysically, we might be able to map out the larger extent of the alteration zone. So if we continue to zoom out, we can see that the resistivity low correlating to the alteration is much more extensive. It continues to follow the same bounding fault structure and has a footprint that measures 6.5 kilometers by 1 kilometer. We apply that same shape of the resistivity low to the magnetics. We can see that it also forms a zone of magnetic destruction. I think this helps to highlight this is a bona fide anomaly with both low resistivity and a reduction of magnetic signature. The strong geophysical response we see is very encouraging, as it means that we can use the EM survey to look for other areas that have similar geophysical response. We overlay the resistivity anomaly on the regional geology map and see that it is.
When I listen to this, it reminds me of how you're layering science on top of your thesis or your what you're seeing to form a thesis that helps you to understand and vector into a system. But as you can see, what's beautiful about this is you're seeing several layers of data all pointing in the same direction. Okay, the structural story, the various different rock packages, the geophysical anomalies, the actual mineralization of gold, copper, and moly. All of these layers are how you make discoveries. And earlier I talked about how every company talks about having great people, right? And a lot of them have great people. Some are more committed to a company than they can have 5 or 10 companies they're involved with. But the litmus or what I focus on is the work and the what is produced from that work is to me telling me how good the team is because when they do this great work where they're layering data upon data and they know where to focus and they're coming up with a thesis, these are the actions that are much more important to me than when a company tells me we have great people. I always want to look at the actions because the actions tell me about their greatness. Denny Laviolette, Greg Matheson, Tim Froud, these are all really talented exploration and guys, and they're very committed to pirate gold. And when they put their thinking caps together, that's why the product is such a good amount of work that's already been done as they're getting into drilling. I mean, this is all sort of pre-drilling work that they've done. And now they've started that drilling, which is very exciting. They get the truth machine poking holes in there.
Associated with the concentration of copper and molybdenum occurrences around Crippleback Lake. Looking further northeast along that same fault corridor is the cluster of copper molybdenum occurrences around Buccaneer Pond. As the airborne magnetic EM has yet to cover this region, we are eagerly anticipating what results will come from that part of the survey and whether or not this region shows a similar geophysical response, which could further multiply the potential scale of the alteration. Next few months at Crippleback are going to be very exciting. Two drill rigs have been mobilized to this part of the project with several thousand meters of drilling planned to test the heart of the resistivity anomaly. This is the most exciting regional target this company has ever tested, and something that was too big to ignore. Alteration on this scale doesn't occur through natural weathering. You need something geologically large to create it. Hopefully, in the coming weeks, we'll get to find out what that is. In addition to testing the resistivity anomaly, we have drilling planned to extend the gold-bearing fault in Scurvy Pond. This will allow us to better assess its potential for orogenic gold. Lastly, the Crippleback isn't just one target. It's an area of geology with multiple deposit models and ripe with potential. Plans to drill test the true orogenic potential will get underway this summer as we await further drilling permits at Buckler Ridge, Buccaneer Pond, and elsewhere along the 35 kilometers of strike length on the Valentine Fault. 2026 will be the year we get some answers about Crippleback.
So there you go, folks. Greg did a great job of sort of putting all that data together and explaining it. And lots stood out. He really left it
Brace
on.
your joints.
Oh, sorry,
My cheek
sorry,
feels
sorry.
the back.
Uh, he really did a wonderful job there to describe what all the data that they put together, the layers of information, and how that's helping them to that's sort of the breadcrumbs. And the last note he talked about there really gets me excited. I've said it earlier in the video, how he talks about multiple geological events or regimes, if you will, or environments. And this is really exciting because you could see, where you get that primary mineralization and secondary and the enrichment, and that really juices up the system. It shocks me as well as what Greg said that this is such a highly prospective project, part of the overall Treasure Island project that's only seen a handful of holes and really deserves to have hundreds of holes into it. And so it's really early days for Crippleback. They're still pounding away on the northern end of the Treasure Island project at the Moosehead, where it's orogenic, high grade in drill holes, trying to understand that system. Now they're getting busy with Crippleback, and they're able to do that because not only do they have the funding, but they have those key people involved: Denny Laviolette, Greg Matheson, Tim Froud. So you've got a few really brilliant geologists there that can put their thinking caps on, and then they've got great people to run the programs, great drillers. So this is a very exciting company, and you want to do your homework, like I always end my shows with. Keep in mind that they are a sponsor, a gold sponsor of my work. So they're basically a title sponsor on all the work that I produce now. And as you can see up there or over there somewhere, that background is in all my shows now. And the disclaimer is in the description below. As I said, sponsor and look at the disclaimer. Talk to your financial advisors before making any investment decisions. And most importantly, is doing the homework. I talked earlier about how actions speak louder than words, and my words are always at the end of every show for you to do your homework. But my actions in my various different videos and my interviews are to help you with that homework process. So, as they say, I eat my own cooking. I do my homework and I help present content that helps you do your homework as well. And I do that because I think that the most successful investors are the most informed. And you want to be a well informed investor, which gives you a better chance to be a successful investor. And that's why I always end my shows with that sort of stuff. So, on that note, have a great day, and we'll talk to you soon.